Your mission: build an unmanned aerial vehicle from scratch.
We need a vehicle that can go into a forest fire and potentially deliver a payload. So it needs to be able to navigate an obstacle course and carry as much payload as possible and deliver that to the objective site.
It has to be strong enough to carry a bucket of water, and you have a limited amount of time to make it through the obstacle course.
And how much time were you given?
That was 5 minutes.
And how much time did you take?
I think maybe about a minute and a half.
So you were fast.
So went through it, didn't try to do anything fancy, just slow and steady through the whole course, make it there, get back, call it a day, and be happy.
Their invention? Airwolf, completely designed and built by mechanical and aerospace engineering students at North Carolina State University. With its unique combination of size, speed, and agility, Airwolf took first place at a regional design competition at Clemson University. That earned the team a trip to Montreal to compete in the international finals. Flying an unmanned aerial vehicle, or UAV, this big can be tricky.
A lot of it boils down to pilot nerves. You have a large vehicle that's capable of inflicting potentially a lot of damage, a lot of risk involved inherently in a system like this. You have very high RPM motors, maybe about 12,000 RPM. You've got carbon fiber props spinning. And then initially, when you're tuning the aircraft, the flight computer has no idea what it's flying. So the vehicle could be way too responsive, so you just say a little bit of left and she'll roll.
But in Montreal, Airwolf didn't roll over. Despite being an underdog, the team came in third overall.
Your design was not expected to do well in Montreal, and you came in third.
Right.
How did you do that?
I think, again, that has to go off back to the idea of we had a system that worked from regionals. We made the decision to just leave it as it is, and I think a lot of other teams that had succeeded at their regional competitions, when they went to internationals, they had the mindset of we have a new chance to start over again. And so you end up in the same boat of, well, now they're at internationals and they have bugs to work out.
If it ain't broke,
don't fix it.
Faculty Program Director Matthew Bryant says the team, all volunteers, took less than a year to go from receiving the challenge to winning the competition.
The unusual challenge here was building a heavy vehicle. So that was what they did a nice job of interpreting that and coming up with a solution that had enough power and enough size, but also enough maneuverability to be able to win this competition.
But they also had a secret weapon.
how important is the leprechaun hat to Airwolf?
Flight critical. That is, in the criticality path, that is the top line.
Can you put it on for us, please?
This is the luck of the Irish, and without them in Guinness, this whole project probably would not have been possible. So, thank you, Irish.
But Airwolf isn't the only award-winning design. This is Red Rescue Rover, nicknamed Smiley. Its mission?
We had to deliver a payload, which was going to be rice or beans, across a series of obstacles and deliver it into a hole and then return to where we started. This was supposed to simulate a disaster relief scenario where we're delivering food to somebody in need, say in like New Orleans when they had the hurricane come through.
Smiley and Wolf Tank, the other robot designed and built by state engineering students, first had to go through water, then sand, then climb stairs to deliver the payload.
We were actually very upset at first because we didn't make it back to the beginning. We were like, oh no, we didn't do it. We came all this way, we didn't do it. And then every robot after that just kept not making it. We're like, guys, we have a chance.
And you won.
And we won. We took home first and second. Our two were the only ones that got all the way to the end.
This hands-on experience for the student teams is invaluable in landing a job after graduation, especially in robotics and UAV development, two of the hottest industries in the world right now.
Unmanned aerial vehicle or drone type technology, I know that a lot of them are interested in doing something like that. But a lot of what they'll learn in this type of project would be applicable in a wide variety of applications. Some of them will go into the automobile industry. Automobiles are becoming very computerized, and a lot of the technology in automobiles is common to what they've learned through this project.
Some of the greatest advancements that are going on right here on campus, right here in Raleigh, North Carolina. We know that the number of uses is beyond anything that we can imagine. I think what we know today is that they're going to be used throughout all sorts of industries. It'll start off as really a flying camera, and there's all sorts of applications there from agriculture, insurance, industries, law enforcement, security. But then it goes beyond that. We're talking about enhancing their capabilities, obstacle-rich environments, better imaging characteristics, more data throughput, and now you're talking about even more applications, and now they become really more robotic.
They also focus on safety, not only for the students, but for anyone near the vehicles, because many people have concerns, even fears, about drones.
We ensure that our students are safe. There's a lot of spinning propellers that are going very quickly. Once drones are up flying, are they going to be falling out of the sky, that type of thing, crashing onto our homes, onto our cars? I have a lot of confidence that students like these will be participants in making the technology safe.
All new technologies create some level of angst. There's always a question of privacy, a question of security, safety, and these are important problems. And when it's new, you don't really understand it, we all have to learn. But this is going to be common day experience, just like many other technologies.
So as students design the next generation of robots and UAVs, they're learning valuable lessons about technology and safety. But maybe the best lesson they learn through this project is making robots is fun.
If you're having fun with it, you'll want to know, well, why did we do this? Why can't we do that? Why can't I change this up? What's the reason for it? And you're motivated to learn it.
You might even come up with a cool invention, like a self-flipping graduation tassel. And even though sometimes you fail, you learn from your mistakes.
If you don't fail, then you're not going to learn. So, I mean, it's perfect. I mean, this is Velcroed on, these are zip tied on, so, I mean, it's stupid if you're not going to, if you're afraid of failing, you're not going to succeed.
But even with a few failures, these students have achieved great success, and they're well on their way to a high-flying future. They did it by working hard and having fun while doing it. Mission accomplished.
Yeah.
I think I'm most proud of our students.
No matter what they choose, they're gonna do very well.
And the impact ultimately that we can make in the state and beyond it. And it's kind of exciting to be a part of it.